Hi students, now let us see the important terminology called inductive reactance. Now in the earlier derivation, we have seen this equation, that is I naught is equal to V naught by omega L. While deriving the equation, we have this I naught is equal to V naught by omega L, which implies, look at this, V naught by I naught is equal to omega L. See, ನೀವು equation ಗಮನಿಸ್ಕೊಳ್ಳಿ, V naught by I naught is equal to omega L ಅಂತಂದ್ರೆ it is exactly similar as V by I is equal to R according to Ohm's law. That means what? In place of R, there is omega L. In place of R, there is omega L. That means what? Omega L stands for some kind of opposition to the flow of AC by inductance. That kind of inductive it is called inductive reactance. It is an opposition to the flow of AC by inductance coil. ಅರ್ಥವಾಯ್ತಾ ಮಕ್ಕಳ ಇದು? See, we have I naught is equal to V naught by omega L in the earlier derivation. ಇದರಿಂದ rearrange ಮಾಡಿಕೊಂಡ್ರೆ V naught by I naught is equal to omega L ಬರುತ್ತದೆ. See, according to Ohm's law, the term V naught by I naught represents what? Some kind of opposition to the flow of current. In the case of DC circuit, it is called R, resistance ಅಂತ ಕರಿತೀನಿ. But ಇಲ್ಲಿ ನಾನು omega L ಅಂತ ಬಂದಿದೆ, it is called inductive reactance ಅಂತ ಕರೀತಾರೆ. It is simply called, it cannot be called as resistance only. It is called inductive reactance. Okay, that means what? ನೋಡಿ ಇವಾಗ ಅದನ್ನ ನಾನು ಈ ತರ ಬರೀತೀನಿ. V naught by I naught is equal to omega L, and I can say here omega L is called inductive reactance. Omega L is called XL. It is called what? Inductive reactance. ನೋಡಿ, omega L is equal to XL ಅಥವಾ XL is equal to omega L. ನೋಡಿ, ಹಿಂಗೂ ಬರೀಬಹುದು. Or what is called omega? 2 pi F into L. See, this is the equation for inductive reactance. ನಿಮಗೆ ಕೇಳ್ತಾರೆ, what is inductive reactance? ನಿಮಗೆ ಕೇಳಬಹುದು. ನೋಡಿ, ಈ ತರ ಬರೀತೀನಿ. So what is, ನೋಡಿ, question is like this. What is inductive reactance? What is your answer? This is your answer. This must be your answer. It is the effective opposition. It is effective opposition offered by inductance coil to the flow of AC. It is an effective opposition offered by inductance coil to the flow of AC. It carries 1 mark. Okay. Equation ಬರೀತೀನಿ. It is given by XL is equal to omega L ಬರ್ಕೋಬಹುದು, or XL, X into L ಅಲ್ಲ, ಅದು X suffix L is equal to 2 pi F into L. So this is a very important equation. ಇಲ್ಲಿ ಬರಿಬೇಕಾಗತ್ತೆ, where F ಅಂದ್ರೆ ಏನು? Frequency of AC. Frequency of AC, and L is called self-inductance. L is called self-inductance of coil. Now, what is the unit for inductive reactance? The unit, SI unit for inductive reactance. Inductive reactance is ohm. ಅಲ್ವಾ? ಯಾಕಂದ್ರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಯೂನಿಟ್ ಏನು? ಓಮ್. ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್ ಕೂಡ ಅಪೋಸಿಷನ್ ತಾನೆ, ಓಮ್ ಓನ್ಲಿ. ಸೊ SI ಯೂನಿಟ್ ಫಾರ್ ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್ ಇಸ್ ಓಮ್ ಓನ್ಲಿ. ರೆಸಿಸ್ಟೆನ್ಸ್ ಗೆ ಯೂನಿಟ್ ಇರುತ್ತೋ ಅದೇ ಇರುತ್ತೆ. ಸೊ ಹಂಗಿದ್ರೆ ಓಕೆ ಮಕ್ಕಳ. ಸೊ ಇದು ಇಷ್ಟು ನಿಮ್ಗೆ ಐಡಿಯಾ ಬರ್ಬೇಕು ನಿಮಗೆ. ಸೊ ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್ ಡೆಫಿನೇಷನ್ ಗೊತ್ತಾಯ್ತು, ಈಕ್ವೇಷನ್ ಗೊತ್ತಾಗಿದೆ, ಟರ್ಮ್ಸ್ ಗೊತ್ತಾಗಿದೆ. Now, how does inductive reactance depends on frequency? Directly. If L is constant, ಆಯ್ತಾ? So XL depends on F. ನೋಡಿ ನಾನು ಇಲ್ಲಿ ಬರೀತೀನಿ. Note-ಅಲ್ಲಿ we have this. We have XL is equal to 2 pi FL. How does XL depends on frequency? Directly. See, directly it depends. So XL directly with frequency. Now, if you plot a graph of XL versus frequency, nodi, if you plot, you can plot a graph. This is called XL, this is called frequency. You will get a curve like this. So as the frequency increases, inductive reactance increases. Like this you have to understand. So graph ಗೊತ್ತಾಯ್ತು ನಿಮಗೆ. So ನಿಮ್ಗೆ 1 mark ಅಲ್ಲಿ ಕೇಳಬಹುದು. How does inductive reactance depends on frequency ಅಂತ? So it is directly proportional to frequency. So ಇಲ್ಲಿ ಬರಿಬೇಕಾಗುತ್ತೆ ನೀವು. So inductive reactance XL varies directly as frequency F. XL varies directly as frequency F. So this you must understand. So ನಿಮಗೆ ಯೂನಿಟ್ ಗೊತ್ತಾಯ್ತು ಆಯ್ತಾ, ಫಾರ್ಮುಲಾ ಗೊತ್ತಾಯ್ತು, ಗ್ರಾಫ್ ಗೊತ್ತಾಗಿದೆ, ಫಾರ್ಮುಲಾ ಗೊತ್ತಾಗಿದೆ. ಎನಿ ಡೌಟ್ ಅಬೌಟ್ ದಿಸ್? ಓಕೆ, ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್ ಮೀ ಎನಿ ಕ್ವಶನ್ ಇನ್ ಕಾಮೆಂಟ್ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ. ನಿಮಗೆ ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಕೇಳ್ಬೋದು ನೀವು, ಆಯ್ತಾ? ಸೊ ಫೈನ್. ಸೊ ಇವಾಗ ಇದಾದ್ಮೇಲೆ ನೋ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಆನ್ AC circuit containing pure capacitance. AC circuit containing pure capacitance. Okay, fine.